Hello, so this is geometric constraints number 1. I realized I hadn't had a video for this one, so I'm putting one together right now for you. So this is on Canvas. What you're going to need to do is jump onto the assignment, which is geometric constraints number 1, and you're going to download the file here, and we're going to go through and we're going to create, we're going to fix all of these sketches using geometric constraints. So I'm going to go up here to where my downloads was and open that up. It should open Inventor automatically. It might take you a little bit longer than mine. Mine was already open, so it was automatic. But just to introduce you to Inventor, this is a sketch, so we're working on 2D. And to navigate, if I hold down the scroll wheel, I can pan back and forth like that. I can also zoom in and out using my scroll wheel, like so. So our first thing we're going to do is we're going to edit this sketch. So right here, see how there's this sheet 1 and sketch 1. So this whole area right here is called the sheet, and then this is called the sketch. So I'm going to double click either on the sketch here or here, and it will open editing mode. So I can double click on this and I can change the name. So I'm going to say Mr. Barlow. We'll just say that this is A1 and say OK. That updated here. So now there are 12 boxes. We've got 4, 8, 12, a couple of rows, a couple of columns, and each of these has a specific geometric constraint that we're going to use to fix these sketches so they look so they match the instructions. So the first one says make perpendicular. So we're going to use a tool in this area. These are all geometric constraints. We're not going to use all of them, but we will use a few to better understand how they work. I just realized we're going to need to get rid of. There we go. Now you can see more. So we've got our make perpendicular. So I'm going to use this one right here. It's right in the middle. So it's called a perpendicular constraint. That makes angles 90 degrees. So click that one. Notice my cursor has changed. So it has a little T right there. That's a square. I'll click here. And not like a four-sided square, but like a square to measure 90 degrees. That turns that into that. Looks good. And to get rid of this, to deselect that tool, I can right-click and say OK, or I can just click the Escape key. Either way will work. So this next part says make all lines parallel. So I'm going to go up here. I'm going to kind of look for a constraint that looks like it would be parallel. This one looks like it might be, but it's actually the equal one, so we don't want that one. So I'm going to try this one. And it does say parallel. What's nice about these is if you hover over them, it'll kind of give you a small description of what it is and then an example of what it does. So we go parallel, and I'm just going to click from here to there, and then there to here. Doesn't really matter what order you go in, just as long as all the lines are parallel. So they can be kind of spaced differently, but it doesn't really matter. As long as they're parallel, you're good. Okay, and then the next one is make arcs tangent to lines. And yes, I spelled arcs wrong. That's actually how you spell arc, like a boat. So I'm going to fix that. Make it a C. Okay. And a tangent line is a smooth transition from a line to an arc. So here, this you can see there's like almost a corner here. There's a really small one there that you can't really see. So I'm going to go over here and go to tangent, which is this circle with the little slash on the top. And I'm going to make all 4 of these connections. So I'll click here and there, boom, bam, and that one. So now all 4 look good. So now it looks more like a track. And it's okay if yours is a little bit smaller, it looks a little more squat, kind of avocado shape, just as long as all of those arcs and lines are smoothly connected. You're good. Okay. We'll pan over to this one. So this is the second option, and the second definition of tangent is that it passes through only at one point. So I'll go tangent here. I'm going to click this circle, this line, circle, and line. And voila, I've done it. Cool. All right, so now I'm going to hit the escape key to get rid of that. And now I can go on to the 5th one. So this is fix the center of the circle and then make the endpoint coincident to the center point of the circle there. It's the end point and the center point. So first things first, I'm going to fix the center of the circle, and that's using the lock key. So I click lock, click there, and then I can use coincident, which just means, coincident, so the 2 points overlap each other. So I'm going to click this one, I'm going to click this endpoint here, and the center point, and now they line up. I can right click and say OK. Cool. Now if I try to move that, it'll stay in place. I can resize the circle, I can even move this around, but that center point is fixed. Okay, so next one is make all circles concentric. Now concentric is a fancy word that just means they share the same center point. So I want all 3 of these circles to have the same center point. So I'm going to go up here to this little circle thing here, and I'm just going to click the center point, or the outside of the circle, on all of those, and they should all line up like that. So it kind of looks like a bullseye. Alrighty. And then next one is make the lines collinear. So collinear means that the lines are on the same path. Right now, they're not really parallel, and they're not really, they don't line up very well like this. So I'm going to use this one right there, which is collinear. I'm going to click this one and that one, and notice how they line up right now. So it looks like they're overlapping. If I right click and escape out of the tool, I can click and drag and pull these apart so that there's a gap between them, and it makes it really obvious that these are on the same pathway. So this makes them both not really parallel, kind of parallel, but just on the same line, so that they would overlap if you squish them together. Okay, and then the next one is make lines horizontal. So there are 2 tools right here that look similar. This one's vertical, and this one's horizontal. They both kind of look like they're cones, but that just represents the horizon line, and this would be like a vertical wall. So I'm going to go horizontal, click here, and here, and there you go. Those are all nice and fixed. Alright, so then the next one is vertical, which is right next to the horizontal key. So I'm going to click that one. And same idea, just going 90 degrees the other direction. Now I'll go straight up. Perfect. Very easy, huh? So now, if I go to make all sides equal, this is a isosceles triangle. So I need to make all of these the same to make it equilateral. So first things first, this little dot right here, if I click and drag on that, you'll notice that this triangle is actually broken. So I need to fix that. And I can use my coincident, click there. I'm just going to click this endpoint, bink, and then this one, like that. And now those are connected, but my sides are no longer, well, they weren't before, and they're still not the same length. So what I can do to fix that is, in the corner, there's this little equal tool. I can click the sides, like that, so now those ones are equal. Now I can make those ones equal as well. And now if I try to move it or scale it or anything like that, all of the sides remain the same. And it's pretty nifty. So, and it's okay if yours is at a different angle, if it's going to turn sideways, or it's a different size, that's okay. Just as long as the sides are the same. Then it's good. Alright, so this one, make the circles the same size. So I'm going to use the equal tool again. I'm just going to go boom, boom. And now if I try to scroll or kind of pull on these, they're going to scale up at the same rate. Cool. Very easy. If I go to the last one, so it says line up all the centers of the circles horizontally. So I could click and drag these and get these to line up like that. But the problem with that is they're not locked. I can still move them even after they've been lined up. So a way to make sure that they stay in place is to use the horizontal tool. I click the center points here and here, here and there. And now if I try to move these up and down, they are constrained, so it can only stay with that dot. And so the dots have to line up horizontally. And that's pretty much it. So as long as you've got all, it looks more or less like this, and I can tell pretty easily that they're collinear or that they're concentric or perpendicular or whatever, then you'll get full points on this. So the last step is the submission. So I'm going to say finish sketch. So that gets me out of sketch mode. And I'll go over to here where it says file, and I'm going to export, and I'm going to export this as a PDF. So, I'm going to click that one, and it's going to say, what do you want, or where do you want to save it? And best place is in your student drive, which is usually your F drive. I don't have one, so I'm just going to drop mine on my desktop or something like that, and then maybe rename it and just maybe give it my name like geometric, and then maybe that. And then not required, just I'll be able to tell whose it is once it's submitted anyway. So I'll click save, and then on Canvas I can go in and say file. Let me show you what this looks like, a student view. To submit it, I'll go down to where to go? Oh, it's showing this because I've already done a practice submission, so I'm going to say new attempt. And you go to this where it says upload, then you click this little rocket, and you can find your assignment. Mine's right here. I'll say open. It should upload here, and then you just say submit, and then you'll get the cool confetti if it's on time, and you're good. And that's it. So if you have any questions, please let me know. Otherwise, I think that's pretty much a wrap. So thank you for watching.